Hello everyone, Mr. Fawcett here, and we are back with another lesson on proofs. So today's a special day because you get to start writing proofs completely on your own. Whereas the last couple lessons, well, I guess we've written algebraic proofs completely on our own before, but we're going to write some geometric proofs on our own today. So in the last lesson, I gave you either all of the statements or a mix of statements and reasons, and you kind of just had to fill in the missing pieces. Again, today you're responsible for coming up with all of the pieces and making sure they're in the correct order. So you're probably going to struggle a bit today. These are not easy problems to work through. Proofs are a different concept than what you're used to, and they also require a different type of thinking. So if you're struggling, that's okay. Just stick with it. I promise you, the first time you write a proof completely on your own, it's going to feel quite satisfying. And then I guess I wouldn't say they all get easier from there, but they do get to be more fun once you have that confidence that you are able to write a proof on your own. Before we get there, though, let's talk about three problems. Just fill in the blank for these. Pause the video, fill in the blank, and then come back and see if you did them correctly. Okay, so number one says, if the measures of two angles are blank, then the two angles are congruent. Well, the angle measurements of congruent angles have to be equal for the angles to be congruent. Number two, if two angles form a blank blank, then they are supplementary. So a little hint. Here's an example of what they're talking about. Angle 1 and angle 2 here form a linear pair, which means they are supplementary. Linear pairs are adjacent angles that form a straight line. Or rather, all lines are straight, so they just form a line. Number three, if two angles are complementary to the same angle, so if angle 1 is complementary to angle 2, and angle 3 is also complementary to angle 2, then those two angles must be congruent. Here's an example, though, before we fill that in. So let's say angle 1, so the measurement of angle 1 equals 50, and the measurement of angle 2, if they're complementary, angle 2's got to equal 40. And we're in degrees. So if angle 1 is complementary to angle 2, and angle 3 is also complementary to angle 2, well, angle 3 has to also be 50, right, if it's complementary to angle 2. And that means that angle 1 and angle 3, those are going to be congruent. This is an example of the transitive property, right? The transitive property says if A equals B and C equals B, then A equals C. Okay, let's get started with some proofs. So again, the way it's going to work today, you're going to pause the video, see if you can work through these proofs, and then play the video and see how you did. I would go through these one by one, so I'd try a proof, watch a video, try a proof, watch a video, just so you kind of get an idea of what's going on. A good place to start with a proof is with the given, and then try to build off of there. So start with the given, pay attention to what you want to prove, and then try to fill in the steps in between. You may or may not use all the boxes. It kind of depends on the different approach you take. If you end up needing more boxes, that's fine. Just draw them onto the end or split a box, split a row into two rows. You can approach that as however you need to. Okay, so let's look at the first proof. It says, given angle 1 and angle 2 are right angles, prove that the measurement of angle 1 equals the measurement of angle 2. So our given is just going to be what they tell us. Angle 1 and angle 2 are right angles. Now, we need to eventually prove that the measurement of angle 1 equals the measurement of angle 2. But what can we take from this first statement? If angle 1 and angle 2 are right angles, what does that mean? Well, it means measurement of angle 1 equals 90 degrees, and the measurement of angle 2 equals 90 degrees. Now you could put those in separate boxes, you can put them in the same one. When you're using the same reason, I like to put them in the same box if I have space. And this is just definition of right angle. Or right angles, rather, plural. If those two angles are both equal to 90 degrees, well, then they must be equal to each other by the transitive property. So measurement of angle 1 equals a measurement of angle 2. Transitive property of equality. Okay. Again, we didn't use all the boxes. That's okay. We have proved what we needed to prove. All right, onward. Try to squeeze as many boxes as I can here. All right, so we are given two things. We're told that the measurement of angle A equals 60 degrees, and we're told that the measurement of angle B is equal to 2 times the measurement of angle A. We eventually need to prove that angle B and angle A are supplementary. So I'm just going to start with the given. I'm going to put it all in one box. So the measurement of angle A equals 60, and the measurement of angle B is equal to 2 times the measurement of angle A. All of that was given. So if we look at the given, is there anything else we could write based on what the given is? Does it allow us to come up with any other equations? Well, if I know that the measurement of angle A is 60, can't I use that to find the measurement of angle B, right? I could just use some substitution. So if the measurement of angle A is 60, then I can substitute that in my other equation. So I get the measurement of angle B is equal to 2 times 60. Substitution, property of equality. Okay, now we just need to simplify. So measurement of angle B is equal to 120. Some of you may have put down multiplication property of equality. If something is a if something is a property of equality, it means that we're doing it to both sides. So we're only multiplying on one side here. So we're just simplifying the expression. Okay, now I know that the measurement of angle A is 60 and the measurement of angle B is 120. I need to prove that they're supplementary. To do that, if we think back to the definition of supplementary, I need to show that the sum of their measures is equal to 180. So is there an equation I can build where I can say that the sum of their angle measurements is 180? There is. Let's take a look at what I can do here. So I can take this equation, oops, need to be on my pen. So I'm going to take this equation right here, and I'm going to add it to this one. So if I add the left-hand sides of those equations, I get measurement of angle A plus the measurement of angle B. Okay, right? That's what's on the left and the left. On the right-hand side, I get 60 plus 120. You can add equations together, right? If I give you, and you've done this before when you've done like solving systems using elimination, right? So you may have something like 2x minus y equals 15, and you had another equation like 3x plus y equals 10. And you would add these equations together to eliminate the variable. Because if you added them together, you would get another equation that's true, right? You get 5x, the y's would simplify, and you'd be left with 25, and then you could go ahead and solve. But the idea is that you can add two equations together, and you'll get a third equation that is also true. Once we have our third equation built, we are just going to simplify it. So the measurement of angle A plus the measurement of angle B is equal to 180. Again, that's just simplifying. And I realize we forgot this reason up above. So when we add two equations together, that is just the addition property of equality. Addition property of equality. Okay, so we came up with our third equation, we simplified it, and then if we're at the point where we know that these two angles add to 180, well, we are at the point where we can say they are supplementary. So I can jump down to my last statement. Angle A and angle B are supplementary. And that is just the definition of supplementary. We may start abbreviating supplementary SUPP. Okay, next one. So we are told that angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, and we need to prove that the measurement of angle 1 is equal to the measurement of angle 3. I believe this is pretty similar to a proof we did yesterday, where we did something, but it was supplementary instead of complementary. So first thing I'm going to do is I'm just going to write down my givens. So I have angle 1 and angle 2 are complementary. I'm going to abbreviate that COMP. And angle 2 and angle 3 are complementary. It's because I'm running out of space here. So you can put those in separate boxes. You can put them in the same box. I'm squeezing them into the same box just so I do not run out of boxes here, at least on my screen. So what does that tell us if I know that angles are complementary? Well, if we think back to the definition of complementary, we know that the two angles that are complementary have to add to 90 degrees. So measurement of angle 1 plus the measurement of angle 2 equals 90. And then I should have another equation. The measurement of angle 2 plus the measurement of angle 3 equals 90. Again, that is just definition of complementary angles. If you just put definition of complementary, that's okay. We don't have a definition of complementary segments or a definition of complementary triangles, so it's assumed that you're talking about angles. Okay, I have two equations. Is there any way for me to combine them? Okay, well, there's two equations that both equal 90. So if two things both equal the same thing, right, these two angles and these two angles both equal 90, then we can set them equal to each other. So I can say that the measurement of angle 1 plus the measurement of angle 2 equals the measurement of angle 2 plus the measurement of angle 3. Two correct answers here. The best answer, transitive property of equality. The second acceptable answer would be substitution property of equality. But I'm not even going to write that because transitive is the best answer. Transitive is used when two things equal the same thing, so you set them equal to each other, right? It's the A equals B and C equals B, which implies that A equals C. Okay, this right here looks pretty close to what I want to prove, right? But we have this measurement of angle 2 on both sides. So is there a way for me to get rid of the measurement of angle 2 from both sides? Well, sure is. Maybe I just subtract it from both sides, right? So I subtract it from both sides. I'm left with the measurement of angle 1 equals the measurement of angle 3. Subtraction. Property of equality. You will lose points if you don't put property of equality, because that shows me that you're doing it to both sides. So just make sure you remember the POE or the POC, depending on whether we're doing an equation or a congruency statement. Okay, this one is all done. I believe we have two more. Yes. Okay. This one, given x is the midpoint of segment AY, and y is the midpoint of segment XB. Prove that segment AX is congruent to segment YB. Let's just start with our given. Before we start thinking, let's write down what we're given and see if we can build from that. So X is midpoint of segment AY. And y is midpoint of segment XB. And what you could do, you could go over to your diagram and just kind of think about this. It may help you before you start to write the formal proof. But if x is the midpoint of AY, then these two segments right here have to be congruent, right? They're going to have the same length. If y is the segment of XB, or if y is the midpoint of XB, well, then XY has to have the same amount of tick marks as YB, because they're both the same length. So this kind of shows us right here that all three of those smaller pieces have the same length, which means that segment AX is going to be congruent to YB. We just have to find a way to show that using symbols and manipulating some equations or congruency statements. So let's think again about what the midpoint says. If something is the midpoint of a segment, well, if x is the midpoint of a segment, x is the midpoint of segment AY, then we know that AX equals XY. And if we know that y is the midpoint of XB, then we know that XY is equal to YB. I'm leaving the bars off the tops of those letters, because the midpoint is talking about lengths rather than congruent segments. So no bar when we're just talking about lengths. And my goodness, I am forgetting my reasons. First one was given. The second one, again, we use the definition of midpoint here. Definition of midpoint. Okay, as always, once we come up with multiple equations, there's usually a reason we've done that, right? It's usually because we want to try to combine them later on. Not every time, but that's been a pattern we've seen so far, so we might as well see if that works here, right? And right off the bat, we notice that AX and YB are both equal to XY. So if two things are equal to the same thing, then they must be equal to each other. By now, I think we are starting to understand that this is the transitive property of equality. And then this looks very similar to what I want to end with. I just need to have a congruency symbol rather than an equal sign. To do that, I'm allowed to just convert like this using the definition of congruent segments. Definition of congruent segments. And it looks like we just have one more left for today. Okay, we are told that angle 1 and angle 2 are supplementary, and that angle 1 is congruent to angle 3. We now need to prove that angle 2 and angle 3 are supplementary. You'll notice that a lot of these proofs are fairly similar. That's just because we haven't explored as many geometric concepts yet. So 3 units down the road, we'll have a lot more geometry knowledge, which will allow you to do much more complicated types of proofs. But for right now, we just have to work with your background knowledge and the stuff that you've currently learned this year. That being said, I'm going to write down the given. So angle 1 and angle 2 are supplementary. And I'm actually going to just keep this by itself. That may cause me to run out of boxes at the end, but I'm just going to keep this because I want to do something with this piece of the given before we talk about something else. If angle 1 and angle 2 are supplementary, then I should be able to write an equation, right? I should be able to say the measurement of angle 1 plus the measurement of angle 2 equals 180. And again, that would just be definition of supplementary angles. Oops. Okay. Now, I need to prove that angle 2 and angle 3 are supplementary. So if I could somehow get there to be a measurement of angle 3 instead of a measurement of angle 1, then that would show that angle 3 and angle 2 have measurements that sum to 180. So this is going to take me back to my given, right? I have this angle 1 is congruent to angle 3. So whether you wrote that down up here or whether you write that down here, it doesn't matter. I'm going to just keep it down here because I didn't originally put it up there. Either way, it's going to be given. Okay, your givens don't all have to be in the beginning. You can use them as need be. If I know that angle 1 is congruent to angle 3, well, remember I can convert this to a measurement. So I can say the measurement of angle 1 equals the measurement of angle 3, definition of congruent angles. I'm allowed to convert back and forth using that definition of congruent angles, just like I can convert back and forth with my segments, going from the lengths of segments to congruent segments. Once I have this equation right here, I can do some substitution. I can take measurement of angle 3 and substitute it in for measurement of angle 1. I am going to have to break this into 2 though, just so I have enough boxes. I'm going to need one more. I'm going to break that into 2 real quick. All right. So my next line is going to be the measurement of angle 3 plus the measurement of angle 2 is equal to 180. Notice that this is not transitive substitution. This is just regular substitution. We'll talk about that in just a second. Substitution, property of equality. So the 2 equations we're using here, I'll just circle them. I'll circle them in green. So I'm using this equation right here, and I'm using this one right here. For transitive substitution, we have to have 2 equations that have the same quantity on both sides, right? This represents transitive because 2 things are equal to the same thing. A and C are both equal to B. If I look at my 2 equations right here, there's not one side of the equation that's the same for both. So when I'm substituting one thing from the other, or one thing into the other, it's not transitive, it's just regular substitution property of equality. If you're ever unsure whether it's substitution or transitive substitution, probably best to just put substitution because that covers everything. Whereas if you put transitive, like if you put transitive here, that would actually be incorrect and you wouldn't earn full points. So if you're ever unsure, best to just stick with substitution property of equality. Okay, once I have this equation, right, measurement of angle 3 plus the measurement of angle 2 equals 180, I am now ready to say that they are supplementary. By the definition of supplementary, because I've showed that they their angle measurements sum to 180, which is what the definition of supplementary states. Okay, that is going to finish up today's set of proofs. Again, proofs are not something that we're done with just because this is the end of this is the last lesson in the unit. We're going to be doing proofs with whatever content we're currently studying, right? So right now we're doing proofs with very basic angles and segment diagrams. When we talk about triangles, we'll start to do proofs with triangles. When we talk about transversals and parallel lines, we'll start to do proofs with those types of angles. So proofs aren't gone away. We've just started. Hopefully you're starting to become a little bit more confident with how to approach proofs, how to set them up, how to read them, etc. But you will continue to get more practice as we move forward. Okay, enjoy the rest of your day, and I certainly look forward to seeing you next video.